Hello students, in this lesson of trigonometry, you will be learning about unit circle and we will be discussing the sign of trigonometric ratios that depends on the angles and the quadrants. So let's quickly begin. This is a coordinate axis, x-axis and y-axis. It divides the whole coordinate plane into four parts. These are quadrants. So first quadrant, second quadrant, and here this one is third quadrant, and here is the fourth quadrant. The angles in the quadrant, let's discuss the angles in the quadrant. So in the first quadrant, if you take an angle, anti-clockwise angle with respect to positive x-axis, that angle theta will lie between 0 to 90 degrees. In the second quadrant, the angle will lie between 90 to 180 degrees. In the third quadrant, the angle will lie between 180 to 270 degrees, and in the fourth quadrant it will be between 270 to 360 degrees. But if you take the angle clockwise from positive x-axis, that angle will be negative angle. Okay, so in the fourth quadrant, if you're taking an angle this theta clockwise, so it will be between minus 90 to 0 degrees. If you take an angle clockwise angle in the third quadrant, that will be between minus 180 to minus 90. In the third quadrant, it will be minus 270 to minus 180 degrees, and in the fourth quadrant it will be between minus 360 to minus 270. Now let's discuss how trigonometric ratios becomes positive or negative depending on different angles in different quadrants. Okay, so as you have already sketched their graphs, you already have an idea about how the graphs look like. So we'll be starting with sine graph. So here is the sine graph. This is pi over 2. Pi over 2 means 90. Pi is 180 degree. 3 pi over 2 is 270 degree. 2 pi is 360 degree. So as you can see that the sine is above x-axis, means positive between 0 and 180 degree, and between 180 to 360 degree it is negative. So it means that the sine theta will be positive in the first and the second quadrant, and the third and the fourth quadrant sine will be negative. Sine theta is positive in the between 0 to 180 degree, and it is negative in between 180 to 360 degree. So that means sine theta will be positive in first and second quadrant. So positive, positive, negative, negative. It is negative in third and fourth, positive in first and second. For cos theta, now let's sketch the graph of cos theta and see where it is positive and where it's negative. So I'm going to sketch the graph of cos theta. So this is a graph of cos theta. As you can see that it is positive between 0 to 90 and negative in between 90 to 270, and 270 to 360 it is positive. So that means it is positive in the first quadrant, negative in the second and third quadrant, and positive in the fourth quadrant. So let's write for cos theta, it is positive in the first quadrant, and negative in the second, negative in the third, and positive in the fourth. Another is tan theta. So let's sketch the graph of tan theta to analyze. So I'll remove this and sketch the graph of tan theta. So this is a graph of tan theta. Between 0 to 90 it is above x-axis, means it is positive. Between 90 to 180 it is below x-axis, means negative. Between 180 to 270 it is positive, and 270 to 360 it is negative. So tan theta is positive in the first quadrant, negative in the second, and positive in the third, and negative in the. In terms of quadrant, we understood that which trigonometric ratios will be positive or negative. Now we'll be discussing unit circle. So this is a unit circle. This point will be 1 comma 0. This is 0 1. This point is minus 1 0. This is 0 comma minus 1. Now if point P is making an angle theta with the positive x-axis, OP is making an angle theta with the positive x-axis, it means this OM is x and PM is y, right? That's what it means. Now can we write, and as it is a unit circle, this point is, this OP length is 1 unit. Now in right triangle, OM divided by OP is equal to cos theta, right? OM divided by OP, adjacent over hypotenuse. So OM over 1 is equal to cos theta. OM is your x, so x is equal to cos theta. Similarly, we can say that PM divided by OP is equal to sin theta. So PM is x, PM is y, y over 1 is equal to sin theta. So y is equal to sin theta. So we got this x coordinate as cos theta and y coordinate is sin theta, as it is a unit circle. Now in the first quadrant, x and y both are positive. X is greater than 0 and y is greater than 0. And we know x is cos theta. So cos theta will be greater than 0, which implies cos theta is greater than 0, sin theta is greater than 0. So both are positive. That's what we discussed in using graph. Second quadrant, if any point P lies over here, so here the x coordinate will be negative, y will be positive. So x is less than 0, y is greater than 0. That means cos theta will be negative and sin theta will be positive. Why? Because x is cos theta. So if x is negative, cos theta is negative, y is sin theta, so y is positive. In the third quadrant, x is less than 0, y is less than 0. So that means cos theta is also negative, sin theta is also negative. Okay, let's see the fourth quadrant. So the fourth quadrant, I'll write here, fourth quadrant. In the fourth quadrant, any point P, if you take, x will be positive and y will be negative. So that means cos theta is positive and sin theta is negative. This we have already discussed above based on the graph. And you know about tan theta, right? Tan theta, let me explain you the tan theta. So if you will find tan theta from here, tan theta will be y over x, right? Tan theta will be y over x. So here we can say that tan theta is y over x. So y and x both are positive, that's why tan theta will be positive. Here tan theta, which is y over x, y is positive but x is negative, that's why it is negative, because it is y over x, positive divided by negative is negative. Tan theta here y is negative, x is negative, both are negative, so tan theta will be positive. Because negative negative gets cancelled. For let's say tan theta equals to minus 4 over minus 5, which will be 4 over 5, right? So it is positive because x and y both are negative. In the fourth quadrant, tan theta, as it is y over x, y is negative, x is positive, so then it is negative. Okay? Now I'm going to explain you the inverse trigonometric functions. This concept will help you to find out the solutions of trigonometric equations. So we'll be learning y is equal to sin inverse x. Y is like a function x. Y is a function of x. Y is equal to tan inverse x. So like any other inverse function, they follow all the property of the inverse function that they are symmetrical about the line y is equal to x, and inverse is only defined for one-to-one function. But as you can see in the GeoGebra, that sine is a many-to-one function, because if you sketch a line, let's say y equals to 0.5. If you sketch this line, a horizontal line, it is intersecting the curve at many points. So this is not one-to-one function. Inverse cannot be defined for the whole domain. That's why we need to restrict the domain. So we'll be restricting the domain. Now from where to where we can restrict the domain? So as if you start from here, go on the top, and then if you start going down, it can be it becomes many to one function. So to satisfy that it is one to one only and around zero, what domain we can take? So as you can see here, that if you take a domain between minus pi over 2 to pi over 2, minus pi over 2 to pi over 2, it will be a one to one function. So I'm going to change this and sketch another graph of sine between minus 1 to 1. So I'll use this function sin x, start value minus pi over 2, end value pi over 2. So as you can see, this purple one, it starts from here minus pi over 2 and it goes to pi over 2. Okay, let me remove this normal sin x graph. So if you remove the normal sin x graph, as you can see here, between this domain from minus pi over 2 to pi over 2, it is one-to-one function. It is the horizontal line is intersecting the curve only at one point. So this is one-to-one function, and if it is one-to-one function, its inverse is defined between this domain. So this is the largest possible domain where the sin inverse can exist. As you know that domain of the function becomes the range of the inverse function. The range of the function becomes domain of the inverse function. So sin x has a domain for inverse function. It has a domain between minus pi over 2 to pi over 2. It means that will become the range of sin inverse x function, and it has a range from minus 1 to 1. So domain of inverse function should be between minus 1 to 1. Okay, so I'm going to sketch the graph of sin inverse x, and you will see that I'm going and you will see that it follows all the properties of sin x. So sin inverse x. See, this is a graph of sin inverse x. Let me remove this line. So this is a graph of sin inverse x. As you can see that they are, this is sin x, this is a sin inverse x. They are mirror images of each other along the line y is equal to x. So let me sketch the graph y is equal to x. As you can see, this is y is equal to x line, and they are mirror images of each other. Now the point what I was making over there that the domain of the function, the domain is minus pi over 2 to pi over 2. That will be the range. The range of the inverse function is minus pi over 2 to pi over 2. Range of the function, you can see it is between minus 1 to 1. So that the domain of the function will be between minus 1 to 1. Okay, this is, it starts here, this is minus 1 here, and this is 1 here. It cannot be shown, but you can take it that this is minus 1 and this is plus 1. So domain of the function was minus pi over 2 to pi over 2. That becomes the range of the inverse function. So range is minus pi over 2 to pi over 2. I'll show you. Yeah, let me change the settings now. So this is x-axis. X-axis is, let me change with 1, and y-axis I'll change with pi over 2. So as you can see, yeah, so I've changed it. Now you can see that this is fx is the inverse function, that's sine inverse x, and the domain is minus 1 to 1 for the inverse function, and the range of inverse function is minus pi over 2 to pi over 2, which was actually minus pi over 2 to pi over 2 is the domain of the function. Domain becomes range and range becomes domain for the inverse function. Okay, I hope this concept is clear, so you should make a note of it. Now quickly summarize it, whatever we have discussed in GeoGebra, that for inverse to be defined, the sin x should have a domain between minus pi over 2 to pi over 2, and range is 0 to 1, right? As we know that inverse function, the range of the function becomes the domain of the inverse function. That's why the sin inverse x has a domain between minus 1 to 1, or you can also write this as minus 1 to 1, and the range of the function is minus pi over 2 to pi over 2, which is the domain of the range of the inverse function, the sin inverse x, is minus pi over 2 to pi over 2, as it is the domain of the sin x. Okay, we can also write range as minus pi over 2 sin inverse x to pi over 2. Okay, so that was the explanation for sin x. So this is the graph of cos x. Domain is all real numbers and range is between minus 1 to 1. And this is 1 here, and this one is minus 1 on y-axis. I have kept in terms of pi just to explain you the inverse function concept. So here, as you can see, that cos x is a many to one function. It's not 1 to 1. So we cannot find out the inverse in this domain. So whenever there is a many to one function, and if you want to find out the domain, you need to restrict the. So whenever there is a many to one function, and you need to find the inverse of the function, so you need to restrict the domain. So in this case, if you see around 0, so 0 from 0, this is from 0 to pi over 2, it is 1 to 1 function. And then pi over 2 to pi, it's also 1 to 1 function. So if you take from 0 to pi, it is 1 to 1 function. But if you go beyond, then it becomes many to 1, because it fails the horizontal line test, right? So we have to take between 0, x is equal to 0, to pi. Let me show you why we are going to take that. Let me sketch the graph of y is equal to 0.9. So as you can see, this is 0.9 and y is equal to minus 0.9. Just to explain you the concept, I have drawn horizontal lines. So as you can see that these are intersecting, the horizontal line is intersecting many points, inverse cannot be defined. So we have to take the largest domain where the inverse is defined. So if you start from 0, from 0 to pi there is only one pi over 2 there is only one intersection, and pi over 2 to pi over 2 to pi it's also only one intersection. So we can take between 0 to pi, but if you go beyond then it fails the horizontal line test again. So the largest possible domain where the inverse is defined is 0 to pi. So I'm going to sketch the graph between 0 to pi and explain it to you. So I'll sketch the graph of cos x between, this is cos x, use the function uh, use the function command here, and you write the start value. The start value is 0, end value is pi. Okay, let's sketch it. So this is the red line, it shows the graph which is 0 to pi. Let me remove this. For bigger domain, for all real numbers I'm going to delete it. Okay, so this is the graph of cos x between 0 to pi, and as you can see here, this this passes the horizontal line test. Like, there is no problem with it. If you draw a horizontal line, it will intersect, the horizontal line will intersect only at one point. So this is one-to-one function between this domain, right? Between 0 to pi. So between this domain, inverse is defined. So let's sketch cos inverse x. Cos inverse x. Okay, this is the cos inverse x graph. Now let's first analyze cos x between 0 to pi. So between 0 to pi, this is the domain, and the range of the function is -1 to 1. Okay, -1 to 1. For the inverse function, the domain of the function becomes the range of the inverse function. That's why the range of the inverse function, it is between 0 to pi, and it lies between -1 to 1. This is the domain of the inverse function. In domain of the inverse function is between -1 to 1, which is the range of the cos x, right? So let me write it properly here. So for cos x and cos inverse x, so we have restricted the domain between 0 to pi, or you can write x lies between 0 to pi. Okay, x belongs to 0 to pi, this is set notation form. And here the range of the function y belongs to -1 to 1. Okay, this is the range of the function. You can also write -1 to 1. Now for cos inverse x, the range becomes the domain, right? So domain of the cos inverse x is x belongs to -1 to 1, or you can write x lies between -1 to 1, and range of the function is the of cos inverse x is the domain of the function. So domain is 0 to pi, so range lies between 0 to pi. Cos inverse x will give you a value between 0 to pi. Okay, now we will understand for tan x, and let me sketch the graph. Let me sketch the graph y is equal to x to show you that they are symmetrical about the line y is equal to x. So this is, as you can see, this is the function and this is the inverse function. They are symmetrical about the line y is equal to x. It satisfies the property. Now I'm going to sketch for the graph of tan x and explain you the inverse function, inverse tan inverse x. So here is tan x for all real numbers. They don't exist for minus pi over 2, pi over 2, 3 pi over 2, because you know why they don't exist at minus pi over 2, pi over 2, the multiples of odd multiples of pi over 2, because tan x is also sin x over cos x, right? And wherever the cos x will be 0, it will be infinity. Tan x is also many to one function. It means it is not one to one function. So we need to make it one to one so that we can define the inverse of tan x, right? So the domain what we can take is between minus pi over 2 to pi over 2. It is 1 to 1. Sketch the graph. Tan function minus tan x minus pi over 2 to pi over 2. Okay, this is the graph. Let me remove this tan x for all real numbers. So this is the graph. Between minus pi over 2 to pi over 2, it satisfies the horizontal line test. There's no problem. Now we can find out the inverse. So let me sketch tan inverse x. The domain of the function becomes the range of the inverse function, and the range of the tan x here is minus infinity to infinity, and that's why the domain of the inverse function will be minus infinity to infinity. The range of the tan x is minus infinity to infinity. That's why the domain of inverse function, that is tan inverse x, will be between minus infinity to infinity. I'll sketch the graph and show it to you. So tan inverse x. As you can see here, the domain is all real numbers, but the range is between minus pi over 2 to pi over 2. Okay, and they are symmetrical about the line y is equal to x. So I'm going to write for tan x domain, to make it for the inverse, is x belongs to minus pi over 2 to pi over 2, right? That is, x lies between minus pi over 2 to pi over 2, and the range of tan x, range, we know that it is minus infinity to infinity, that is all real numbers, or you can also write minus infinity to infinity, right? Or you can write that y belongs to minus infinity to infinity. Okay, let me write with black color, so minus infinity to infinity. That's how you can write. That's a range. Now for tan inverse x, the domain of the function is actually the domain of tan inverse x is actually the range of tan x. So range of tan x is minus infinity to infinity, so that's why x belongs to minus infinity to infinity, or you can say x belongs to R, all real numbers. A range of tan inverse x is the domain of tan x, which is minus pi over 2 to pi over 2. So y belongs to minus pi over 2 to pi over 2, or you can write tan inverse x goes from minus pi over 2 to pi over 2. Okay, thanks for watching the video.